All right, so we're going to do exponential equation, and this is the last type of equation that we're going to be doing. Okay, so we have done quadratic equation, we've done inequality, we've done equation and inequality with absolute value. Also with the equation involving, or inequation involving the unknown in the denominator, and also with the simultaneous equation by substitution and elimination. We've done 3 equations and 3 variables. Okay, that is one of the last things that we did. Okay, and now we're going to finish this with exponential equation. Now, the reason why we do this is because when doing some other stuff later, you're going to be using some of these equations. Okay, it could be a quadratic equation, or it could be an absolute value equation. So you need to know how to do it. All right, so here we go. The main thing when solving this exponential equation, okay, somehow you really want to have the same big number on both sides. Okay, that is basically what you're going to be doing. Okay, so you need to manipulate. Sometimes you're going to be manipulating only one number. Sometimes you're going to have to manipulate both of them. Okay, but your aim is to have the same big number on both sides. Okay, and then when you achieve that, then you can get rid of them. And then you're going to equating, the powers, and then it's going to be so easy. Because for all this equation, at the end, you're going to be solving one of those, one step or 2 step equation that you did in year 7. All right, so it's so easy. Okay, but let's see. Question 1. So we need to find the answer for x. So when 3 is raised to x, the answer is 81. All right? How are you going to do that? Well, this actually is simple. In your calculator or in your head, you're going to find 81 as a power of 3. Okay, so you're going to do, in your calculator, 3 to the power 1, well, doesn't work. 3 squared, doesn't work. 3 cubed, doesn't work. Until you find the one that matches, the 81.
Definitely.
Okay?
Yeah.
What is it?
The power of 4.
Yeah, so you do 3 to the power of 4. Okay, and then it's done. Okay, can you see that now we have 3 and 3, big numbers? Yeah. So then you can eliminate them. So therefore you say x is equal to 4. That's it. Okay, so very
Too easy.
simple. Okay, so yeah, it's easy, but say that again. Algebra is fundamental. Okay, so you need to remember your algebra. And I said to you, and I said it again, algebra is extremely important. You need to master everything that we did in year 10 and everything that we've done this year. Okay, so you need to know your algebra very, very well. All right, question 2. Question 2, we have 5 to the power of 2x minus 1 equal to 25. And then I really want to have the same number. I think it's kind of obvious what we have to have in here. Okay, so you can see that if you express 25 as 5 squared, then it's done, basically. Because then we equate the powers. So therefore you say 2x minus 1 is equal to 2. 2x is equal to positive 3. Oops. 2x is equal to positive 3. So therefore x is equal to 3 on 2 or 1.5. All right? So far, so good. Okay, the next one. Question 3. Question 3, we have 8 to the power of n is equal to 4. All right? There's no way that you're going to make 8 equal to 4 somehow, or 4 equal to 8 somehow. Okay, so that means that in here, what we're going to have to do, we're going to have to reduce this number to 2. Okay, can you see that 8 is the same as 2 cubed? Okay, so I say 8 is the same as 2 cubed, and that is raising to the power of n. And what about 4? 4 is 2 square. Okay, so you do 2 square. And then you got to remember something that you did in year 8. Okay, so when you raise a power to another power, then do you remember that we have to multiply these two? Okay, so that means that this is going to be 2 to the power of 3n. And on the other side, you're going to have 2 square. So therefore, 3n is equal to 2. So n is equal to 2/3. Okay, so it looks like exponential equation at this point is pretty easy. It is easy. All this question are, I would say, easy. But it will require some algebra, and also it will require you to remember some stuff that you did previously. But in general, I would say that this is not too bad. All right, so here we have 2 to the n is equal to 16. Okay, Ella, any suggestion? What should I do on the other side?
Reduce it to 2 to the power of... Oh, I know that doesn't work.
Yeah, it does.
It does?
2 to the power of...
4.
Yes. Okay, and then you have n is equal to 4. All right, is enough?
Mm-hmm.
Yeah. Okay, so we're gonna. So do you want to take a photo of this? Take a picture. Yeah.
Of all the questions.
Yeah, everything that we've done, so I can wrap this off and then continue with the solution.
Oops.
Nice.
Right?
Excellent. Thank you.
All right, so far, so good. Okay, next question is question 5. Question 5 is 1 over 49 to the power of k is equal to 7. Right. Can you see what you have to do? Okay, so tell me, what should we do first?
Well, can you make you times the 7 by a negative 2, and then that just gives you 1 over 49, which would be to the power of 1. So k would just be 1.
No.
That is very ingenious, but it wouldn't work.
What?
Yeah. I know what you're saying. I know what you're saying, but that is, I think that you.
Like 7 to the power of negative 2 is 1 over 49.
But wouldn't you have to times the other side by that too?
No. Okay, have a look. We don't want to make this harder, right? So step number 1, we're going to express 49 as 7 squared. That's it. We won't do anything on the other side. So what we do 1 over 7 squared to the power of k equals 7. All right, are you okay with that?
Ah!
Are you okay with that?
Yeah.
Okay. Now, can you see, that 7 squared is the same as if you do 7 to the negative 2? Okay, so we're going to bring this, but we need to do it step by step. So we're going to bring this up to here, and when you do that, this square becomes negative 2. Okay, so we're going to say 7 to the negative 2 bracket to the power of k is equal to 7. By the way, I'm going to put 7 to the power of 1, just to see, what the power is. And then we're done, basically, because then we're going to say, 7 to the power of minus 2k have to be equal to 7 to the power of 1. Then negative 2k is equal to positive 1. So k is equal to negative half. All right. Okay. Got it?
Got it.
Got it. Good. Okay, in the same way, we're gonna do question 6. Okay, so we're gonna use the same process basically. So I'm gonna write the question. What should I do first?
Change the 1,000 to 10 cube.
Yes. Okay, so we're gonna express 1,000 as a power of 10. So you're gonna do 1 over 10 cube. Also, you're gonna express 100 as a power of 10, so it's gonna be 10 squared. Okay, can you see that our aim is to have the same number on both sides? That's it. Okay, and then this is 10 to the negative 3, in bracket to the power of k, and then 10 squared. And then we do what we did to the other one, so we're going to have 10 to the power of negative 3k is equal to 10 squared. And therefore, we equate the powers, and then we're going to have that k is equal to negative 2/3. All right. Okay, happy with that? Right, can I write the answer for 5?
Yes.
Yeah, okay. Okay, so now we're going to do question 7. Okay, so we have 2 to the power of 4x plus 1, and that have to be equal to 8 to the power of x. At this point, I think it's pretty obvious for you that we have to make that equal to somehow. Okay, so we're going to say 2 to the power of 4x plus 1 is equal to 2 cubed, and then to the power of x, right?
Mm-hmm.
Okay, and then we're going to say 2 to the power of 4x plus 1 is equal to 2 to the power of 3x. Okay, so therefore equating the powers, we're going to have 4x plus 1 is equal to 3x. And then we're going to have, x is equal to negative 1. Right? Okay. So we have question 8. So we're going to do all these questions together, and then you're going to do the rest of them from the textbook.
Sean is coming, he says he's running late.
All right.
Of course he's from.
I know.
Tell
I said
him-
he's going to belt you.
Tell him to hurry up.
Yeah. Or Gonzo will come into your house.
Okay.
Does anyone know where Amelia is? I have no idea.
Oh well.
All right.
Oh well.
What should we do in this case?
Make 60.
Hmm?
Yeah, we were someone saying that.
Yeah, no, it was him.
Oh, man.
Yeah. So yeah. So we can do 4 square. So 4 square plus 1 is equal to 4x minus 4. And then we're going to have 4 is to the power of 4x minus 2. And on the other side, we have 4 to the power of x minus 1. Right? And then we're done. Okay, so then we say, therefore, 4x minus 2 is equal to x minus 4. Then we're going to have that 3x is equal to minus 2. So x is equal to minus 2 over 3. All right. Okay. So it looks like up to here is all good. No problem. You may have a little bit of problem when you have a square root. Not because they are hard, it's simply because you need to remember something. Okay, can I read them off?
Yeah.
Jesse, are you still copying this one? Yeah.
Do we have to move rooms again today?
Hmm?
Do we have to move room again? Or do we get to stay?
Or we have not have it downstairs.
Yeah.
So we have a double and we have to move rooms. I think you were saying, yeah, is that correct?
Yeah.
Why don't we just kick the other ones out?
Well, that would be nice.
You stand our ground.
Yeah.
They're so dominant. They can go to G7. Exactly. Why do they have to be in this room?
Because they are annoying. They are very annoying.
Shouldn't that mean they don't get to be in this room?
No, it's fine. It's all good. So
Might be
you,
fine to you, sir.
come on, you young people, full of energy. You go to the gym and do, some
Do we now?
running
Quite
and
attached just now.
heavy lifting and all that stuff. Okay. All right, so we have question 9. Question 9 is half to the power of x is equal to 1 over 64 to the power of 2x plus 3. Right. There's no way, well, we could, but there's no way that we're going to make 2 looks like 64, all right? Okay, but I really want to make 64 looks like 2 to the power of something.
Yeah.
And it's 2 to the power of 6? Okay, so here we go. And also I'm going to do, do you understand if I do half as 2 to the negative 1?
Mm-hmm.
Yeah?
I understand.
Yeah.
Okay, so if I change a half to that, is that okay?
Yeah.
We can do that.
So do we have to do that?
Yes.
And you said that this is 1 over 2 to the power of 6. So is that okay if I do just 2 to the negative 6?
Yeah.
Okay, now that you are familiar with this, then we can do 2 to the negative 6 and then 2x plus 3. All right, are you okay with this?
Mm-hmm.
Yeah.
Okay, and then we're going to do 2 to the negative x is going to be equal to 2 to the power of negative 12x minus 18. Right? And then we equate the powers. So we're going to have minus x is equal to negative 12x minus 18. So then we're going to have 11x is equal to negative 18. So therefore, x is equal to negative 18 divided by 11. And then you bubble the answer.
Wasn't too hard.
Okay, and that's it. Right? Okay, so it feels like these are the easiest equation that we've done so far, all right?
Yeah.
Okay? The easiest one. Right, can I wrap it up? Poppy?
Yeah.
Yeah. Okay.
Yeah, it's okay. Oh.
All right, here we go. The next one. Very quickly. Question 10.
Oh, why did I go straight to 11? Oh, I wrote it down so nice.
Okay, we could, but it's no way that we're gonna make 3/4 looks like 27 on 64, but we're gonna do it the other way around, okay? And you can see, you can do this very quickly in your head
Hold on.
after, a little
27,
bit of practice.
64.
Yeah.
You can see that this is the same as 3, this is the same as 3/4 to the power of 3, yeah?
Oh, yeah.
Yeah, because 3 cubed is 27, and 3,
4 cubes.
yeah, 4 cubed is equal to. Okay,